Okay, so what we want to do is we have a goal that we want to achieve, which is to efficiently, so our goal is to efficiently build a high quality software solution to a client's problem. Now, the key components to doing this, there's two things. So the key components to do the above are as follows. So to achieve that goal, first, we need to solve the correct problem. And this really is one of the biggest issues. We don't actually end up often solving the correct problem. We solve what we think is the problem, but it's not the correct problem. So we need to solve the right thing. And the other thing is this issue of how to efficiently create a high quality solution. So we break it into these two parts. And so the first thing we focus a lot on in the course is figuring out how to figure out what the right problem is to solve. And then we talk more in the course about how to do this efficiently with building, get the high quality solution. Now, since this is going to come later, let me give you a little overview of what I actually mean by this. So, all right, so this is the efficiently create part. And so they efficiently create the solution. In this, we really break it down into two things. You need a good design. Now, most of what we have for creating good software design is not being taught in this course, all right? What we do is teach that in the other courses. Now, but let me give you an example. So an example of poor design might very well be, the program's slow, or it's hard to use. Well, these are things that we've dealt with and talked about. This is the subject matter of MSci 240. How do we scale our algorithms with a larger input size? How do we make things efficiently run? How do we get things to go quickly? That's 240. So this is how do we scale things? In 245, this is where we talked a lot about building things with a proper set of components. And the big example we have is the model, view, and controller in the Rails architecture. So we solve our problem by breaking it into the correct components. What's the model? That's actually where we push down a lot of the processing. The controller sort of directs things, doesn't do much. And then we have the presentation layer. And by separating out our solution into these components, we're able to have a better design that's actually more maintainable over time, functions better, and so forth, more reusable, all sorts of things. And then finally, 343 again, this is the human-computer interaction component, dealing with a human. So 342, which is in between these, is sandwiched by the courses about how to end up with good design. But we ourselves don't focus much upon good design in the course. We're using in 342 the prior courses, but then you'll learn more about good design following this. So that's that. But we need to have good design. But we don't talk too much about it in this course. But we also need good construction. And so how do we build it so that it's a high quality solution? How do we do this in an efficient manner? So we will talk quite a bit about this. This is basically when we're going to be talking about things like the team development process. We're going to talk about, again, version control. And we're going to talk about testing. So these are the things that we'll talk a lot about in 342. So to efficiently create it is a lot of this process, tools, testing, this sort of stuff. You know, and the culture, teamwork, all that actually fits partly into there as well. Design, there won't be too much that we'll talk about there. All right, so that's that part. But back to the issue of how do we solve the correct problem? Okay, so that's what we need to first figure out. We need to figure out how to solve. Well, not. We need to figure out what the client's problem is. All right, so a big thing, a factor that affects both of those issues or both of those parts. I think I called them components. So both components of solving our goal is team size. And let's talk about that in terms of solving the customer's problem or solving the correct problem. So let's break this down. We have number of customers. All right. We have our team size. And let me make some notes about this. All right. Grab a different pen. So easiest thing. It's when we have no customers. All right. Our team size is 1. This is what I mean by this is that you solve your own problem. So you've got some issue and you decide to write yourself some software to build it. This is the easiest level of software. And the great thing about it, the magical thing is you can literally read your own mind. It's wonderful. Okay, so what's going on in your head, you're well aware of. You know what your problem is. So you directly go and you build the software to solve that problem. This is great. All right, so determining the correct problem is not an issue if you're solving your own problem. All right, and it also hasn't really been an issue for the most part in a lot of the coursework you take. The instructor gives you a very detailed explanation about, I want you to solve this problem. So it's given to you. You haven't had to actually figure out what the problem is. That's something new in this course. And this is really fundamental to engineering, is it's your job to figure out what the problem is. People don't tell you you don't detail out the problem for you. So you have to figure it out. So yeah, so let's go on to the next thing. We have one customer and one person. That's you. So you're on the team and you're going to solve one client's problem. The biggest thing that happens here is that, you cannot read the mind of the customer or of the client. You can't. At least I can't. So what's the natural result of that is that you will misunderstand. There's no doubt about it. You will misunderstand the customer. Okay? Because there is no such thing as perfect communication. So if you're going to misunderstand the client or the customer, and they're going to try to explain their problem to you, that means you will not have succeeded in solving the right problem, because you'll solve a problem that you think they have, but it's not actually what their problem is. And so already, so this is the issue. It's communication problem. So what we do, all right, so that this is the real thing is, what we do is we go ahead and we develop tools and processes. Probably processes are almost more important, but we certainly have some tools to help us communicate, to solve these issues of misunderstanding. And you can think about, like even the simplest thing. You've probably learned this already. You're working and talking with someone. They tell you something, and you're like, let me say that back to you. Like, let me put that in my words to see if I understand it. And then you repeat it back to them, and they go, no, that's not what I meant. And they try again. Other things that we do, you make a drawing. Oh, wait a minute. Now that we've put it into a drawing instead of words, we can see that that's not what we're talking about. There's all sorts of things. But this is a really big thing. And so we have to have all these mechanisms and processes in place to deal with the issue that we can't read each other's minds. So, of course, it's pretty unusual to have a team size of only one. You're not going to be able to solve very big problems by yourself. So you're going to say, well, yeah, I need some help. And so you're going to increase your team size so you can handle larger problems. So you still have one customer. You're going to have more than one person on your team. What's this going to lead to? Well, now you misunderstand both the customer and your teammates, or your team members. I like teammates. All right. Which leads to trouble coordinating work. You're working as a team, but you're having trouble understanding each other, misunderstanding. You create misunderstandings. It's going to lead to additional coordination problems. And as well, and everyone on the team has a different opinion about what the client wants. So you're all trying to solve the client's problem. We already covered the issue that one person can't read the mind of another person and they're going to misunderstand. But now you've got like a team of 6 people. All 6 people are going to misunderstand. And they're all going to have a different version of the misunderstanding because we all operate with our own sort of biases. This gets to be even a harder problem. So as team size increases, our issues with communication and coordination, our issues of, we have a goal really, which is of shared understanding. We need a way such that the client, the team, they all end up with the same understanding about what we are trying to do. So we have to do a lot of work to get there. It is a real big problem. And of course, you know, in our table here, we can keep going. We could have more than one customer. We'll have more a large team size. All right. Well, what's the problem now? Well, it's not good. You know, I just basically, it's like, OMG, oh my gosh, you know, this is way too much now. It's not, you know, we do have mechanisms and ways of solving this sort of problem, but, you know, now you have lots of customers to misunderstand, or you will be misunderstanding them. You want to understand them. This is an issue, this sort of problem, this notion of multiple customers is not one that we really address in MSci 342. We're going to stop at one customer and a larger team. This actually is not addressed greatly at in our undergraduate program here. What does it take to understand a large body of customers? There's a whole set of methods for that. We tend not to focus on them. You may deal with that to a certain extent in human-computer interaction, where you're looking at lots of different users, and they'll have different usage problems of the system, and so you get a little bit of that. But determining the problem of like a large set of customers, that's a whole separate thing. And we're really going to spend our time here in MSci 342.